Hello guys, today in this lecture we will discuss about the sedative and hypnotic. So sedative are the CNS depressant drug that reduce the excitement and tension of the central nervous system and produce calmness and relaxation of the CNS. And hypnotic are the drug that produce sleep similar to that of the natural sleep, and both the sedative and hypnotic action may reside in the same drug, but it depends on the dose of the drug. A small dose of the same drug may act as a sedative, whereas a large dose of the same drug may act as hypnotic. Now come to the classification of sedative and hypnotic. They are classified into four major classes such as benzodiazepine, barbiturate, non-benzodiazepine, and miscellaneous. In the benzodiazepine, the name will be aimed at form such as diazepam, oxazepam, lorazepam, etc. While barbiturates are further classified into three groups such as long-acting, short-acting, ultra-short-acting, and non-miscellaneous contain the zulfidum and zupiclone, etc., while miscellaneous contain the chlorodiazepoxide and frometazine, etc. Now come to the benzodiazepine. So all the benzodiazepine have a benzene ring fused to a 7-member diazepine ring. You can see the structure of diazepine on the screen. So when it is bound to a benzene ring, and that will be known as a benzodiazepine. In the structure of benzodiazepine, the position R1, R2, R3, R4 and R5 are variable, and they will be changed in every drug of the benzodiazepine, while the other component of the structure will be remain constant for each drug of the benzodiazepine. Now come to the history of benzodiazepine. So the first benzodiazepine is a chlorodiazepoxide on the brand name of Librium. It was discovered in 1954 by Austrian scientist Leo Strembach. Chlorodiazepoxide was synthesized from the work and chemical dye quinazolone trioxide. The certification of benzodiazepine is the midbrain, limbic system, ascending reticular activating system, brainstem, and cerebellum. These are the major sites of action for the benzodiazepine. Now come to the mechanism of action of benzodiazepine. So benzodiazepine facilitate action of gamma aminobutyric acids or gamma. Benzodiazepine receptors are present in the brain and they form part of the GABA A receptor, chloride ion channel macromolecular complex. Binding of benzodiazepine to these receptors activate GABA A receptor and increase chloride conductance by increasing frequency of opening chloride ion channel. These in turn inhibit neuronal activity by hyperpolarization and depolarization block. Benzodiazepine bind at the interface of alpha and gamma subunit on the GABA A receptor. Benzodiazepine binding also require that alpha subunit contain histidine amino acid residue such as alpha 1, alpha 2, alpha 3 and alpha 5 contain the GABA A receptor. For this reason, benzodiazepine show no affinity for the alpha 4 and alpha 6 subunit because they cannot contain the histidine amino acid. It contains the arginine instead of histidine residue. Other site of GABA A receptor also bind neurosteroid, barbiturate and certain anesthetic. The benzodiazepine are classified as diazepam, oxazepam, lorazepam, florazepam, nitrazepam, temazepam, clonazepam, clobazam, chlorodiazepoxide, triazolam, midazolam, and alprazolam. This is the general structure for the benzodiazepine. By changing atom on the position 1, 2, 3, 4 and 5, the drug molecule will be changed and a new benzodiazepine drug molecule will be formed. Now you can see that in this structure the R1 position contain hydrogen, R2 position contain oxygen, R3 position contain hydroxyl, R4 position and 5 position contain the chloride. So this structure will be known as lorazepam, while on the second structure, the R1 position contain hydrogen, R2 position contain oxygen, R3 position contain hydroxyl, 4 position contain chloride, and R5 position contain hydrogen, and this structure will be known as oxaziform. Now in this structure, the R1 position contain hydrogen, R2 position contain oxygen, R3 position contain carboxylic group, R4 position contain chloride, and R5 position contain hydrogen, and this structure is called chlorazepate. In the second structure, the R1 position contain hydrogen, R2 position contain oxygen, R3 position contain hydrogen, R4 position contain chloride, and R5 position contain NO2 group, and the structure is called clonazepam. Now in the structure of nitroziform, the R1 position contain hydrogen, R2 position contain oxygen, R3 position contain hydrogen, and R4 position contain NO2 group, and R5 position contain hydrogen. In the second structure, diaziform, the R1 position contain methyl group, R2 position contain oxygen, R3 position contain hydrogen, R4 position contain chloride, and R5 position contain hydrogen, and this structure will be known as diazepam. Now in the structure of temazepam, the R1 position contain the methyl group, R2 position contain the oxygen, R3 position have hydroxyl group, and R4 and 5 position contain the chloride, and the structure is known as temazepam. In the second structure, such as the praziform, contain this structure, the position 1 contain the methyl cyclopropane, R2 contain oxygen, R3 hydrogen, R4 position have chloride, and R5 position have hydrogen. Now in the structure of halozepam, on the position 1 and there is a trifluoroethane is attached, on position 2 have oxygen, 3 have hydrogen, position 4 have chlorine, and position 5 have hydrogen. In the second structure, praziform have the difluoroethane on position 1, on position 2 there is a sulfur, 3 position have hydrogen, on position 4 have chlorine, and 5 have fluorine. Now in the structure of doxazepam, on position 1 there is a methanol attached, on position 2 there is a sulfur, 3 position have hydroxyl, and position 4 have chlorine, and position 5 there is a fluorine is attached. Now in the second structure, in the structure of fluorazepam, on position 1 there is a tertiary amine attached, on position 2 there is a oxygen, 3 position have hydrogen, position 4 have chlorine, and position 5 have fluorine. So the structure will be known as fluorazepam. So this was all about the structure of different benzodiazepine. In the next lecture, we will discuss about the structure-activity relationship, synthesis, and therapeutic uses of different benzodiazepine. Thanks for watching.